Hi learners, welcome back to CM361. I'm your lecturer Dr. Funman, and today I'm going to share with you this topic under environmental chemistry on air sampling, right? And this regards to two of the goals in the United Nations Sustainable Development Goals, number 13 and 15, climate actions and life on land. So specifically, we dive in what kinds of air sampling. You will be measuring of the atmospheric NO2, the brown color nitrogen dioxide. So first, let's do introductions of this gas called NO2 here, right? NO2, you are not foreign to it. This is a gas you have been introduced when you're young. Let's share some physical property that you know of it. Boiling point 21.1 degrees Celsius, reddish brown color or brown color at a high concentration. That means, right, if it's given out in ppm level here in the environment here, I don't see brown color. It doesn't mean that you don't have a NO2. Now it has a pungent and acrid odor, which means sometimes in an enclosed fixture, even if you don't see any brown gas, but you can smell it, you know there's NO2 here. And back to your inorganic chemistry, it has a point group of symmetry, C2V here. It is bent and in the middle with these bonds here in a canonical structure. So it switches between a dative bond and double bond in each of this NO connectivity. Now, and here, on the left side, you see this image, right? It's a sequence, right, of these ampules of this nitrogen dioxide at 99.9% purity, almost 100%. What we are showing here is demonstrating the equilibrium of the NO2, right? And because it can dimerize to form N2O4, right? And N2O4 is colorless. Therefore, we want to show the transition that right here, in this case, when it's purely NO2 here, how brown, reddish brown it is, and then slowly when it dimerizes, it becomes colorless. Okay, so what you need to know is that the reaction, right, when it dimerizes, because it's bond forming, the standard enthalpy change delta H is negative 57.23 kilojoules per mole. Okay, so how do we make this dimerization happen? It's this equilibrium, and we learn from the Chatelier's principle that when you lower the temperature, the NO2 would form, right, N2O4. Okay, so when you cool it down, you warm it up to a high temperature, it becomes brown again, NO2. Okay, so here it is at negative 196 degrees Celsius, liquid nitrogen, cooling it, right? This is at 0 degrees Celsius, ice cooling, 23 degrees Celsius, 35 degrees Celsius, and 50 degrees Celsius. See the transition, how temperature affects the equilibrium. Now, where do we produce NO2? Okay, so specifically, most of the time in the car engines, right? So what happens is, right, air goes inside your engine, you have combustion of a fuel, be it diesel, be it petrol, right? And then there's oxygen reacting with the nitrogen in the air to form the nitric oxide, 2 NO. And you see here that it is still equilibrium, which means that when you form a bit of NO, you continue also to react with further oxygen to form NO2 here, right? And the good question to ask is, right, why inside a car engine? Because it's very high. N2 as a gas, triple bond as we discussed previously, it is almost unreactive as an inert gas for many reactions, but in this case, in a car engine, normally 85 to more than 100 degrees Celsius, if you accelerate very fast, more than 100 degrees Celsius, it's able to break the triple bond and forces the O2 and N2 in a close vicinity in the very enclosed high pressure combustion system. Therefore, they react, right? And this is not good, right? Because they are polluting. They are released through the car exhaust. Okay? And together, this NO and NO2 are called the NOx. No. Oxides of nitrogen, so in this lecture and further on, we just call them NOx. Okay? The worst thing is, this NOx, it has a synergistic effect, with other pollutants in the air to form PM, the particulate matter, PM10, PM25, and you learn about synergistic effect here in the topic toxicology previously here, right? So they combine to form, small sites of nucleation to form this particle that traps in the bronchiole. Okay, so besides NO2 being a very nasty, gas, that exacerbate a number of health conditions, like the inflammation of the lungs, that can trigger asthma and bronchitis, right? And this also increase the heart attacks and strokes. So you see that, right? We are particularly concerned about the NOx, right? But as a previous slide show, you have a lot of NOx with a synergistic effect with other pollutants. It causes PM, your particulate matter, which is belched out from this diesel exhaust, and these are the kinds of pollutant that has shown to cause cancer. So it is important that, right, we have some kind of filters at the car exhaust pipes, right, to filter all these carcinogenic soot, right, from escaping to the atmosphere. Okay. But the thing is, you see, it's all about transportation. It's about cars and your gas exhaust at the back. The thing is, why would people want to remove these filters, right, if it's already in place? Because if you remove it, you can have a better performance, you can save on the fuels, right, better fuel economy, right? But the thing is, if you remove it, it's illegal. So if you do that, right, you save on the petrol money, and then you go for your LTA inspection, then you might fail and you might need to pay some fine. Okay, yeah. So the other thing is, right, NO2 forms something called the secondary particulate matter when it enters the atmosphere, and this effect is not fully understood yet. Okay, so you see that here, right? How many people does the NOx affect? That's important, because you can talk about the severity, right? But it only affects a very, very tiny population, a specific group, then nobody's going to care. But it turns out that the study shows that air pollution as a whole, right, causes hundreds and thousands of premature deaths. And here we just use Europe as an example. And in a recent study, it puts the number of premature deaths in the United Kingdom to about 23.5 thousand. Okay, so this number, of people affected by the health problems, right, is much greater than those that's reported. And we must not miss the economic cost. Remember, economy, money, drives the economy, drives everything. It also drives some research. And according to the latest figure from the OECD headquartered in Paris, right, the premature deaths and ill health caused by air pollution will cost the United Kingdom government 86 billion. Okay, that was in 2010. So today is 2022. With inflation, with high populations, what do you think the cost will be? Now, across the OECD countries, and Singapore is one of them, OECD, Office of Economic Cooperation and Development, or OCAD in French, the body says that the road transport accounts for half of the total economic cost, okay, in these countries. It's huge.